So in this video, we're going to start looking at the third method for solving quadratic equations called completing the square. And this is certainly more involved than the last two methods that we looked at, but it will also be, we will be able to use this method for any possible type of quadratic equation. We're not going to have the restrictions that we had from the last two methods. So we're on page 12 in the notes. And to get you started, I would like you to go factor that expression over there. And let's see, this is positive, so the same sign, that's positive, so two pluses. And to multiply to 25 and add to 10, I think we'll need 5 and 5. Now, we've seen problems like this over the last couple days, and I've always asked, is there another way we can write it? And someone usually tells me we can write it like this, x plus 5 squared. And I mentioned to you that we would be doing something with that form moving forward, and that's what we're going to look at today. We're going to be focusing on expressions that can be factored into a single term squared, like this. And we call those expressions perfect square trinomials. A perfect square trinomial can be factored into one term squared. So I would call x squared plus 10x plus 25 a perfect square trinomial because we can factor it into x plus 5 squared because it's x plus 5 times x plus 5. Write that down, please. Now, in this problem, notice, actually, do you notice a relationship between 10 and 25? If our constant is half the middle number squared, we will have a perfect square trinomial. We will have a perfect square trinomial if our constant is half that middle term squared. Because half of 10 is 5, square that, you get 25. Then, when I went to factor it, well, if I look at my final answer, x plus 5 squared, I think my factor is just x, and then half that middle number before I do any sort of squaring. So I can factor this thing, if we have a perfect square trinomial, into x plus half that middle term squared. And this is going to be an important shortcut for factoring these types of problems. So I'd like to try to factor these things, and I'd like to try to use that shortcut method. I want to see if these are perfect square trinomials. And if they are, then I'm going to factor them. Let's see, is this a perfect square trinomial? Well, let me take a look at what half my middle term is. Half of negative 8 is negative 4. Negative 4 squared, yeah, that gives me that 16 at the end, which means I have a perfect square trinomial. I can factor this thing into x and then half my middle term before I do any squaring, so x minus 4 squared. If you were to write this thing out twice in FOIL, you would get that original line back. In letter B, we have x squared plus 2x plus 36. If I want to see if this is a perfect square trinomial, well, half that middle number squared, half that middle number is 6. Squared, yep, that gives me the 36 that I want. I have a perfect square trinomial, which means it can be factored into x, half the middle term, x plus 6 squared. And if you wrote that out twice and FOILed, yeah, you'd get your x squared plus 12x plus 36. This last one looks unpleasant, but we can still do it. Half my middle number is negative 3/2. If you square negative 3 halves, you're going to get positive 9 over 4, exactly what that constant is at the end. So even though there's a fraction, this is still a perfect square trinomial. I can factor this into x and then half the middle number before I do any squaring, so x minus 3 halves in parentheses squared. Again, as I've been saying, if you wrote this thing out twice and FOILed, even though it's a fraction and messy and stuff, you would get that original problem back. The next thing we're going to do, we're going to look at some not quite perfect squared trinomials and figure out what this last number has to be for it to be a perfect squared trinomial. Once we do that, we're going to do some factoring. To figure out the missing number over here, I need to do half my middle number, so half of 2, which I'm going to square. Half of 2 is 1, squared is 1. If I stick a 1 in that space, now I'm going to get a perfect square trinomial. I can factor this into x, and then half my middle number, half of 2 is 1, x plus 1 in parentheses squared. If you write that thing out twice and FOIL, you get the original problem back. In letter B, what number is going to go at the end? I need to do half my middle number squared. Half of negative 12 squared. Okay, half of negative 12 is negative 6. Squared gives me 36. I'm going to stick a 36 over there. What would you factor that into? And make sure when you type in your answer, you include the raised to the second power. My factoring should be x, and then half my middle number before I do any squaring. So half of negative 12 is negative 6. I'm going to say x minus 6 squared. If I wrote it out twice and FOILed, I'd get the original back. Letter C. What's going to go in that space? And give me the answer as a fraction. Half my middle number is 5 halves, and I'm going to square that. Well, 5 halves squared is 25 fourths. See if you can do the factoring, and it's going to be a fraction, and that's okay. We should get x, and then half the middle term before we do any squaring, so x plus 5 halves in parentheses squared. So, what we're actually doing when we're filling in this space is it's called completing the square. We're completing this to turn it into a perfect square trinomial, and we're going to see more of that later. Moving on to page 13. We're now going to talk about how we can use some of these ideas to solve quadratic equations. Take a look at letter A. X squared plus 10x plus 25 equals 4. What you should notice about the left side is this thing over here. It's a perfect square trinomial, like we saw on the previous page. I know it is because half my middle term, half of 10, is 5, squared gives you 25, that number at the end. Yeah, it works. I can factor this into x, and then half my middle number. X plus half of 10, x plus 5 squared equals 4. If you don't believe me, write out x plus 5 twice, and FOIL. You would get x squared plus 10x plus 25. I now want to try to solve this thing that I'm getting. How do you undo a square? I hope you didn't just say take the square root. I hope you said take the positive and negative square root. That's what I'm going to do. I'm going to say x plus 5 equals plus or minus the square root of 4. What is the square root of 4? 2. X plus 5 equals plus or minus 2. I now need to get the x by itself. I'm going to subtract 5 from both sides. As far as the right side goes, if this is 2, 2 minus 5 is very different than negative 2 minus 5. I'm going to get very different numbers, so let's not do that. Let's write this as x equals negative 5 plus or minus 2. Let's just not combine the negative 5 with the 2 yet. But now, why don't I go ahead and do that? If you do the problem negative 5 plus 2, you're going to get negative 3. And if you do negative 5 minus 2, you're going to get negative 7. And these are your two answers. Let's see another one of these. In letter B, is what you have on the left side in B a perfect square trinomial? Half my middle number, half of negative 8 is negative 4. Squared gives you, yep, 16. Well, that was kind of convenient that I made these things perfect square trinomials. Because of that, I think you can go factor what's on the left. Tell me what that left side factors into, please. It's going to factor into x, half that middle number, x minus 4 in parentheses squared equals negative 7. Now, how do we get rid of a square one more time? We're going to take the positive and negative square root. I'm going to say x minus 4 equals plus or minus the square root of negative 7. Square root of negative 7, that's I root 7. So I'm going to say plus or minus I root 7. I'm now going to add 4 to both sides. Plus 4, plus 4. We're going to get x equals 4 plus or minus I root 7. Those are our two answers. They happen to be complex number answers. We could also say the answers are 4 plus I root 7 and 4 minus I root 7. But I'm perfectly okay if you want to write it with the plus or minus in the middle. And what we've seen here is the idea behind solving by completing the square. But there's a pretty big problem by solving this way. I was really nice in how I set up those two problems because the left was already a perfect square trinomial. Usually, the left won't be a perfect square trinomial. Usually, we don't already have a perfect square trinomial. So that's kind of an issue. But I feel like I told you this method will always work. The idea is if I give you a problem where we don't already have a perfect square trinomial, we can turn it into a problem that has a perfect square, that is a perfect square trinomial. Here's what I mean by this. We're going to take a look at this problem over here. Is x squared minus 8x minus 36 already a perfect square trinomial? It's not. Half of negative 8 is negative 4. Squared gives you 16, not 36. Here's what we're going to do, and this method is called completing the square. Please take careful notes on this because I think this is a little bit tricky. And also, this is definitely one of those things where I'm going to have to see absolutely every line of your algebra. Step number 1. Get the x's on one side and the constant on the other. Get the x's on one side and the constant on the other. Step number 1 is get the x's on one side and the constant on the other. Well, to make that happen, I'm going to add 36 on the left and add 36 on the right. I'm going to get x squared minus 8x equals 36. I now need to actually do the step where the name comes from. I need to complete the square. I need to add something onto the left side to make this thing a perfect square trinomial. X squared minus 8x plus, I'm going to add something to that side. And of course, you're not allowed to just add something to one side of an equation, so I'm going to add that thing to both sides of the equation. I'm going to say make the left side into a perfect square trinomial. And how do we do that? We do that by adding half of our middle number squared to both sides. Add half that middle number squared to both sides. I'm going to give you a moment to get caught up with copying that down. So I got to figure out what to add. I need to do half my middle number, and I need to square it. Half of negative 8 is negative 4. Square it, you get 16. I'm going to go stick a 16 on the left and a 16 on the right. This now becomes similar to problems that we would have seen on the top of this page. I've got x squared minus 8x plus 16 equals 52. Step 3. I'm going to go and I'm going to factor that left side into a single term squared. I'm going to factor this into, well, x, and then I'll just say half that middle number, before I do any squaring, that factor squared. As we already saw before, this gets factored into x. Half that middle number, half of negative 8 is negative 4, so x minus 4 in parentheses squared equals 52. Remember, this means x minus 4 times x minus 4. If you FOIL it, you'd get the x squared minus 8x plus 16 back. Undo your square. Take the positive and negative square root of both sides. That's going to give me x minus 4 equals plus or minus the square root of 52. I'm going to finish this off by simplifying and solving for x. Simplify this and solve for x. Well, simplify that root. I know that there's a 4 inside 52. Nope, not 4 times 52, sorry, 4 times 13. Square root of 4 is 2, so this is plus or minus 2 root 13 plus 4. Plus 4, we're going to get x equals 4 plus or minus 2 root 13. That's my answer. You could also say, if you want, x equals 4 plus 2 root 13, and x equals 4 minus 2 root 13. This method is called completing the square. I'm going to give you a moment to finish copying that. All we are going to do for the rest of this video is just look at some other examples of this, because this process is going to take us a little while to get used to. But the good news is, it is always going to be the same basic process. Let's take a look at page 14. We're on page 14 in the notes. We want to solve each of these equations by completing the square. Letter A. We need to get the x's on one side, the constant on the other, so I'm going to subtract 41 from both sides. Minus 41 minus 41. X squared plus 6x equals negative 41. I then have to add something to both sides. X squared plus 6x plus something equals negative 41 plus that same something. Can you tell me what we're going to add to both sides? Well, half that middle number, half of 6 is 3, squared gives us 9. I'm going to stick a 9 on the left and a 9 on the right. I need to factor. That left side is going to get factored into what squared? It's going to get factored into x and then half my middle number before I do any squaring. X plus 3 squared, you write it out twice in FOIL, you get that back. This equals, I believe, negative 32. We're going to get rid of our square. We're going to say x plus 3 equals plus or minus the square root of negative 32. You take a moment, simplify that, and finish off letter A, please. X plus 3 equals plus or minus I root 16 times 2. Running out of space, I'm going to come over here. I'm going to get x plus 3 equals plus or minus 4I root 2. Minus 3 minus 3. Another complex number solution. Negative 3 plus or minus 4I root 2. Letter B is going to be a little messier. In letter B, give me one moment just to open another window to maybe make the video a little bit brighter. Okay. In letter B, I first need the x's on one side, the constant on the other. I'm going to move 7x. I'm going to subtract 7x from both sides. And I'm going to get x squared minus 7x equals 5. I now need to add something to both sides, and I'm going to warn you, it's a fraction. Can you figure out what that fraction might be that we add to both sides? Well, let's see. I need to do half my middle number squared. So negative 7 halves, square that, you get 49 over 4. I'm going to add 49 over 4 to both sides. On the left, we need to factor that thing. It's going to become x minus 7 halves in parentheses squared. X and then just half that middle number before we do any squaring. X minus 7 halves squared. If you wrote it out twice and FOILed, you'd get that back. On the right, I think we actually need to go do some addition with fractions here. I'm going to get a common denominator so I can add them. 5 over 1 is going to become 20 over 4 plus 49 over 4. Now I can add, and I'm going to get x minus 7 halves squared equals 69 fourths. I need to get rid of my square. I'm going to come over here to finish off the problem. I'm going to do the plus or minus square root. X minus 7 halves equals plus or minus the square root of that fraction, the square root of 69 over 4. Well, to take the square root of a fraction, all we have to do is do the square root of the top over the square root of the bottom. This is x minus 7 halves equals plus or minus the square root of 69 over the square root of 4. And these are actually both good. How is the square root of 69 good? Because there's nothing you can do with it. There are no perfect squares in there. We're just going to leave it. How's the square root of 4 good? Well, it's just 2. I'm going to get square root of 69 over 2. I'll then add 7 halves to both sides. And I'm going to get x equals 7 halves plus or minus root 69 over 2. Take a moment to finish copying that one down. Letter C. We already have the variables on one side, the constant on the other. It's time to go and add something to both sides. Can you tell me what we're going to add to both sides? Half my middle number, half of negative 2 is negative 1. Squared gives me 1. I'm going to stick a 1 on the left and a 1 on the right. We're now going to factor. What does x squared minus 2x plus 1 get factored into? Don't forget the square. Should become x minus 1 in parentheses squared. On the other side should equal negative 1. You know what? I want to see if you can finish this one off. See what you can do. I'm going to undo my square with the plus or minus square root. X minus 1 equals plus or minus square root of negative 1. Square root of negative 1, that's I. Plus or minus I. I'm going to add 1 to both sides. X equals 1 plus or minus I. Letter D. Can you look at letter D right away and tell me if we're going to get like nice integer things that we have to add to both sides, or if we're going to end up with some fractions when we complete the square? Actually, this is not a great question. You know what, before we do anything, let's get this in the right form. Let's get the x's on one side, the constant on the other. X squared plus 9x equals 3. Now let me ask that question again. This thing I'm going to add to both sides. Integer, or will it be a fraction? Well, I think because that middle number is an odd number, we're going to get a fraction here. 9 over 2 squared, you're going to be getting 81 fourths that you have to add to both sides. I'm going to add 81 fourths. And I think I'm going to zoom in. And I think I'm going to turn on the light, maybe. Maybe that's making it worse. You know what? I think we're just going to keep going, and we're going to see what happens. Actually, let me get one of the lights. Sorry. Okay. I hope this isn't going to mess with the picture too much. See if you can factor. So let me just do the next line of factoring. X, then half that middle number, x plus 9 halves squared equals, okay, on the other side, you need to take a moment, get a common denominator, add those things together. This is 12 fourths plus 81 fourths. I am thinking 93 fourths. See if you can finish this. This is going to end very similar to how we did letter B. Get x equals negative 9 halves plus or minus root 93 halves. 2 more. Letter E. Get rid of that 9. What are you now going to add to both sides? Half that middle number. Half of negative 8 is negative 4. Squared gives me a 16. I'm going to add a 16 on the left and add a 16 on the right. Factor. You're going to get W. Half that middle number is negative 4, so W minus 4 squared equals 25. I'm going to get rid of the square. W minus 4 equals plus or minus the square root of 25. That's plus or minus 5. We'll finish this off by adding 4 to both sides. and we're going to get w equals 4 plus or minus 5. However, if you don't have i's, you don't have roots, you just have like good enough numbers over here, I need you to go a step further and actually do 4 plus 5 and 4 minus 5 and get those two answers. So we're going to say our final answers are really 9 and negative 1. One more, you go do letter F on your own right now. So, x squared plus 6x plus something equals negative 22 plus something. What am I going to add? I'm going to do half that middle number squared. That's 3 squared. That's 9 over there and 9 over there. I then need to see it factored into x plus 3 in parentheses squared equals negative 13. Going to get rid of the square with a plus or minus square root. X plus 3 equals plus or minus square root of negative 13. X plus 3 equals plus or minus I root 13. Minus 3 minus 3. Your answer is x equals negative 3 plus or minus I root 13. There's a lot of work in these problems, but I need to see all these lines of work in the homework. In the homework, if you don't do this and like try solving by factoring or something like that, it will not count for credit, and actually in many cases it won't, just plain won't work. I need to see this completing the square method in all those homework problems that you're going to take a look at tonight. By the way, I told you we could always use this method. However, the problems we've looked at so far have all had a 1 before the x squared. Tomorrow in class, we're going to see what to do if there's some other number before the x squared. And it's really going to be largely the same process with one extra step in the beginning, but it makes it a little bit messier. We'll take a look at that tomorrow.